Okay, so we are going to start looking more at equations in slope-intercept form. This is lesson 4 and unit 5B. Okay, so we're still taking a look at how and why graphs are helpful in real life, but we are going to start this section focusing just on the equation portion of it. Okay. With our y equals mx plus b, or our slope-intercept form, the things you're going to learn is what an equation of a non-proportional line looks like, and then you'll be interpreting what the x and y intercept represent. Okay, our vocabulary words are y-intercept and slope-intercept form. This is a new unit, so you want to start a new vocabulary page, but we only have 2 words this time. All right, let's look at your first page. Little real-world link. Football. An interception in football is when a defensive player catches a pass made by an offensive player. In a non-proportional linear relationship, the graph passes through the point 0b, or the y-intercept. Now, let's take a look at that sentence for a second. In a non-proportional linear relationship. Now, if you remember, for proportional, that was where you had your x and y axis and your line went through the origin. Okay, so remember, with a proportional line, it went through the origin. Now we're talking about non-proportional. So if it's a non-proportional relationship, that means it does not go through the origin. Okay. So doesn't pass through the origin. And so because it doesn't pass through the origin, it passes through the point 0b. Okay, you already knew from activity 2 that the b in the equation is the y-intercept. So if we had our equation y equals mx plus b, the b is the y-intercept. Okay, so you found that out on activity number 2. The y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. So there's our first vocabulary word. So the y-intercept of a line is the y-coordinate of the point where it crosses the y-axis. So make sure you pause and that gets copied somewhere. Okay. All right, there's a short little video that talks a little bit about slope and y-intercept that you're going to watch, and then we'll continue going through this worksheet.
Well, this seems like a good time for a letter. Dear Tim and Moby, how do I find a line's slope and intercept? From Dana. Well, let's start with slope. The slope of a line describes how steep it is. This ramp, for example, is really steep. We can graph it to find its slope. A slope can be defined by its steepness, which you get by comparing its vertical change, or change in y, with its horizontal change, or change in x. Slope, or m, is equal to the change in y divided by the change in x. Right. Some people call that rise over run. Our 2 y values are 6 and 1, and our 2 x values are 5 and 0. The slope for this ramp is equal to the change in y, that's 6 minus 1, divided by the change in x, 5 minus 0. So the slope of this ramp is 5 over 5, or 1. You can find the slope of any line this same way as long as you know the coordinates of 2 points. Maybe you should go first. Oh, almost forgot the intercepts. Well, the intercepts are the points where a line hits the x and y axes. For our ramps line, the x-intercept is -1, 0, and the y-intercept is 0, 1. The y value of the x-intercept is 0, and the x value of the y-intercept is 0. Using a combination of the slope and one intercept, we can write an equation for that line in slope-intercept form. Slope-intercept form is expressed as y equals mx plus b. M is the slope and b is the y-intercept. For our line, y equals the slope, which is 5 divided by 5, times x plus the y-intercept, which is 1. With this method, you can graph a line and find points on it just by plugging in numbers. Using the slope-intercept form, you can figure out all sorts of stuff about a line. Or a ramp. Yeah, we did what we came here to do. To the stairs!
Okay, so you watched a short little video. Some of that may have been review, some may have been a little bit of different information or information said a little bit differently to help you kind of see a little more about the y-intercept and the slope. But what we're going to do here is we're going to take what we know and we're going to do something called derive. The directions say, complete the steps to derive the equation for a non-proportional linear relationship by using the slope formula. So basically we're going to take the slope formula, so we're going to use the slope formula to create an equation y equals mx plus b. That's all they're doing. So we're saying take the slope formula and take 2 points on any line and show me or prove to me that y equals mx plus b will help me draw a line every time. It's basically what we're doing here. Okay, so, oops. All right, so let's take a look first here. All right, so we want the slope formula. The slope formula says y2 minus y1 over x2 minus x1 equals m. Okay, so that's our slope formula. We already know that. What we want to do here in step 2 is we're basically going to take the 2 points we're given in our general line. Now this line has no numbers other than the 0. The only reason we know the 0 is because it's the y-intercept, and the y-intercept always has an x-coordinate of 0. Okay, so all we did was when we have y minus b, that's because we took y2 minus y1. Okay, and for the bottom here, okay, so for my bottom piece, I have x2 minus x1. Okay, so that gets me my 2 parts. So y2 minus y1 would give me y minus b. All right. And x minus 0 gets me my denominator. So we're going to simplify, and I'm going to have y minus b over x equals m. Now, our final goal is to get y equals something. So I've got to start eliminating everything that's around my y that's getting in the way. Okay, it's easiest to get rid of this denominator first. If I had y over 3 equals 10, to get rid of this 3, I would multiply each side by 3. And my 3's would eliminate, because if I made that a fraction, 3y over 3 becomes just y. So any number divided by itself is 1. So we're going to use that knowledge to say, okay, well, I'm going to multiply both sides by x. And if I multiply both sides by x, these x's will cancel. And I'll be left with y minus b equals m times x. Okay, again, we're trying to get y by itself, so that means we're going to add b to both sides. Now, they didn't give you room for that, but that's exactly what's happening. So what happens is that if I have m times x plus b, okay, that's what I have right here. Just so you have a little frame of reference. Let me adjust that really quick. Hold on. Let's back up. So if I add b to both sides, okay, let's take a look at what's happening here. M times x plus b. If you think of the order of operations, you multiply before you add. So I'm going to multiply these two together, and I would get mx plus b. Now, if we think about back to combine like terms, these are not alike. I can't combine them. That's how we end up with mx plus b. Okay, so now we're reaching back into the memory to remember some of these solving equation rules. Okay, and that shows proof why this equation works. Okay, and it shows proof of why this is the slope as well, the m, because that's how we started with that equation. All right. Now, this part is for you to do on your own. For the definition of a y-intercept, think about how you could use that football description that was up above to help remember the definition of a y-intercept. So you decide how you're going to write this down. So your own words. Okay, so let's take a look at the slope-intercept form of a line. Now, I've been saying slope-intercept form, and up to this point, you may not have heard that. You may have just heard y equals mx plus b. Okay, but we're talking about the same thing. Okay, non-proportional linear relationships can be written in the form y equals mx plus b. This is called the slope-intercept form. When an equation is written in this form, m is the slope, b is the y-intercept. So for your definition for slope-intercept form, I would say you should write something including non-proportional linear relationships. It should include y equals mx plus b. And you should include m is the slope, b is the y-intercept. So this would be the bare minimum to include in your definition. You could put it in your own words. You could copy everything that's down right here. Up to you. Okay. One thing I do want you to notice, this little side note. Up to this point, we were looking at y equals mx. And what happened when we looked at y equals mx was we had a line that went through the origin. Oops, that does not. Okay. Went through the origin. Now what's happening is when we get these equations y equals mx plus b, that they're saying it's a non-proportional line. So that's a line that does not go through the origin. Okay? And that spot that it doesn't go through the origin, that gives us our b. Now, when we had y equals mx, if I forced you to put a b, it would be a 0. And if you notice, 0 is our origin. So we've been doing y equals mx plus b equations all along. It just so happened that up to this point, the b was a 0. And if the b is a 0, it's proportional. Now that we're dealing with non-proportional, our b is not a 0. That's why we have a number there now. All this is not necessary. It's just a little extra if you wanted to find a spot to squeeze that in. But that was just more for you to listen to kind of connect the two together. Oops. Okay. Sorry. All right. So here's what I want you to do on the sidebar. We're going to take these two examples, and I want you to copy them down. But before you start copying, I want to go through this with you. So let's look at these two examples. Example number 1. Y equals negative 2x plus 7. Little reminder, m is the slope, b is the y-intercept. So if we look at this equation here, negative 2 is my m, 7 is my b. Slope is negative 2, y-intercept 0, 7. Now, a little side note about how we write the y-intercept. You wouldn't say y-intercept 7. You actually write it as an ordered pair. So it's important that you write this as an ordered pair 0, 7. So for a y-intercept, the x is always 0. Okay? And then example 2, our m is a 3, and my b is not 4, my b is negative 4. If I were to add the opposite, I would end up with a b of negative 4. Very important to add the opposite. And if you notice, y-intercept 0, negative 4. So pause this, take a minute, and get that copied in the sidebar. All right, now let's take a look at an equation, or an example. Number 1, state the slope and the y-intercept of the graph of the equation y equals 2/3 x minus 4. Now if we look at their first step here, they did our adding the opposite, so that instead of 4, my b is a negative 4. So the m is 2/3, b is negative 4. Slope is 2/3, y-intercept is negative 4, or 0, negative 4 would be what I would expect. Okay, so what you're going to do on A, B, and C, so over on A, say slope is blank, y-intercept is going to be 0 and some other number. So for B, you can even write M and B if you wanted to. So take a second, pause, and complete A, B, and C. All right, I wrote the answers underneath just because there's a little more room. This pen, I need more space. But go ahead and check your answers compared to mine, see how you did. If there are any of these that you're unsure about, please make sure you stop me and ask. There's also, if you notice, we have our tutor button up here. If you go to the Schoology post, you'll want to look for the first extra example. I believe it's called finding slope and y-intercept from an equation, something like that. It would be the first extra example. If you click that link, you can see another example of how to do this. Okay, example 2. Now that we're asking you to write an equation if you're given the information. So you're given these two pieces of information. Now it's your turn to write the equation. So we know the slope is negative 3, y-intercept is 4. So the m is negative 3, the b is 0, negative 4. So they want you to write an equation. So all you're doing is you're taking the m and substituting it into the m, and you're taking the b and substituting that number in. So what you end up with is y equals negative 3x. Let's back up a little bit here. You end up with y equals negative 3x plus negative 4. Now you could leave it that way. In high school, you will be expected to convert back to subtraction. For some reason, etiquette-wise, you don't want an addition problem next to a negative for a final answer. It's kind of one of those things like with fractions. You might have to make the fraction improper to do the problem, and then you don't leave the answer improper. Now you can. It's accepted to have an improper answer, but years ago you couldn't do that. So same thing. If you have y equals x, during the problem you might have to make it 1x, but then in the final answer you take the 1 back out. So this is just one of those things that if you do it to get the problem done, you have to undo it. Oh, and I'm sorry, let me back up. On this example, there is another tutor button. So if you look below this video, there's the second extra example will give you a little more information about this. All right, let's take a look at number 3. Write an equation in slope-intercept form for the graph shown. The y-intercept is 4. Okay, so let's take a look at our y-intercept right here. Remember, the y-intercept is where your line crosses the y-axis. Okay, the y-intercept is 4. From 0, 4, you move down 1 unit, right 2 units. Okay, so I'm going to go in green so you can see what's happening here. So we start at our y-intercept. Your y-intercept is always your starting point. Okay, always. This is going to come in handy when we have real life situations as well. Y-intercept is always your starting point. Write this down somewhere on the side. Very, very important. Always start at your y-intercept because that's part of your equation. Then we did a rise and a run. Went down 1 unit, to the right 2. So our rise 1 was down 1 over 2. So the slope is negative 1/2. So we know that our m is negative 1/2 and that our b is 4. There's our negative 1/2 and there's our 4. Okay, so writing an equation from a graph is very tricky. All right, until you get the hang of it. Once you get the hang of it, it's a piece of cake. All right. Now, because this packet only gave us one example of each, your next activity is going to be up front. There's a post about it. It's a practice. However, on the post, I do problems with you. So you're going to want to open up the next post. It'll tell you what to grab, and there'll be a video of me doing some of the problems with you. So this is it for now. Keep this packet somewhere because tomorrow we're going to complete the rest of it. So this is going to be paused to the side. Go look at the next post to see what you need to pick up from the front. And that's it.